before I get started with the talk, I got to do the disclaimer. Nothing I talk about is from the views of my employer. This is all personal research I've done in personal time, after hours. Nothing to do with my employer or me here. Get that out of the way. So that's, some people are still filtering in here. I'll ask a quick question. So what I'm going to do is, everyone who can hold your hand up for the first question. So how many people in the room right now have actually done any kind of mainframe testing or security work or some kind of analysis or anything like that? Okay, keep your hands up. Keep them up. Okay, now, of the people that have your hands up, how many of you were or are currently a system programmer? Okay, so one hand in the entire room is left. Now let me go back. How many of you are Linux and have assessed a Linux machine or a Unix machine? Okay? How many of you have actually administered a Linux or Windows machine? Yeah, okay, so anybody see a problem with this? The people who are assessing the mainframes, which is like a little lot of hands up, they've never administered a mainframe. How many of you actually have an account on the mainframe that you're assessing? Right? So a handful of hands go up. Yeah, it's not. So there's this whole gap of people that are us, the security community, is assessing the mainframe, but we've never administered, we've never built one, we've never set one up. Whereas everyone who does Linux and Windows, they built them from scratch. So now, usually when people talk about a mainframe, this is what they picture in their head. If I say mainframe, this is what you can picture, right? You picture a dude, he's doing some typing, there's a guy fixing a printer jam, you know, there's a room, and it's a room full of machines, and that's all just for one mainframe. Or maybe the 60s, you know, a little tool. Maybe in the 70s. Okay, this is what I think of, right? So it's got a printer, it's got a terminal, it's got carpeting. Yes, data centers have carpeting in them in the time. I'm serious. Like, you can watch videos of people like they tape their mainframe systems and there's carpeting in the room. But really, this is what a mainframe looks like today. It's not that special. It's just like an enclosure with a bunch of CPUs and RAM and all that stuff. It's not really that fundamentally different than a normal computer you would see in a rack. It's just not. It's not that different. It's not that strange. I like to put this so that people can visualize when I start talking about things. Oh, this is what it looks like in the actual data center. Now, part of the point of my talk is the fact that mainframes are definitely not legacy, because I see them described as legacy all the time. Oh, we don't need to implement this policy because it's a legacy system. Calling a mainframe legacy is like calling like Windows 2012 server legacy because parts of the Windows NT kernel are still in the code. That's the same equivalent. Or it's like calling my car legacy because it still uses tires. Even though it's got modern technology all built in, but oh, it's legacy so we can't touch it. Most mainframes, and I'm going to be only talking about ZOS in this talk, I'm not going to talk about Tandem or the other weird Hitachi one. It runs an operating system called ZOS. The current version is version 113. It was released this year. They're switching now, but they used to do annual releases, and they're switching to a biannual release. And they're going to be releasing version 2 a year or so. And that's going to be the newest version of the operating system that has modern built-in things to do. So it's not an old operating system. It's all the same security controls you would expect from other modern operating systems like Unix and Linux and Windows. Now, an interesting statistic is 70% of Fortune 500s run an IBM mainframe. If you ask IBM, it's 90% of Fortune 100s. However, I don't care what the statistic is, but these companies are large companies and they're processing their critical data through a mainframe. They're not running their email servers on it. They're not running their internal intranet site. They're running critical data, your payment, your flights, your train. If you transferred money overnight, those files are going through a bunch of mainframes. That's what is being impacted by the mainframe space. Before I get too far into the talk, a little bit about me. My name is Phil, as you heard. I've always been fascinated with mainframes for some reason. I saw the movie Tron as a kid, and I was like, oh, that must be what a mainframe looks like on the inside. So I was always interested in mainframes. Unfortunately, the only way I could get access to them was by mucking about on like X25 networks, like DataPack, for any Canadians in the room, or like TimeNet, Telenet, SprintNet, all those kind of things. And then that sort of fell by the wayside as I got into school, and then started not wanting to get arrested, and got a career. And then I was able to work a little bit in the mainframes. I was doing mainframe assessments, but I was the same as you guys. I was doing mainframe assessments from an outsider looking in, and not being able to do the proper assessment from the inside, looking at what's actually going on. And then in January 2012, I had the worst experience with a consultant. We brought in a consultant to help us assess a mainframe. They were a PCI mainframe BlackHat security expert. Okay, great. We brought him on. He had like 17 acronyms on his business card for like a whole bunch of things I'd never heard of. I thought, awesome, great. And we brought him in. And I'm asking him simple questions, not challenging questions, real easy questions like, where is the BlackHat database stored? And I'll talk about BlackHat in a bit. That doesn't mean anything to you guys unless some people are nodding their heads, but that's where the database for the password is stored. So I'm like, okay, where's that stored? He's like, oh, it's some file somewhere. And he didn't really know where to find it. So I had to do the research on my own. My favorite example is I asked him what ports are open on a mainframe. Like, how do I find out what ports are open on a mainframe? And he goes, oh, you can't do it. You need to look at a configuration file. And that configuration file is in binary, part of the communication service package. I'm like, all right, I'm sure I can read binary. I'm sure, well, okay. Give it to me. He's like, oh, I don't know how to request for it. People don't generally ask for that. I'm like, you're a PCI assessor. One of your requirements is to look at the open ports. And so I'm in a meeting and I go, do you guys have the netstack command on the mainframe? And the guy's like, sure we do. I don't know what it does, but yeah, we have that command. And he goes, so he types it out, and I get all the open ports. I was like, fantastic. After the meeting, our security expert consultant comes to me and he says, hey, what does the netstack command do? Yeah, so that's when I realized that there was this huge gap. Now, don't get me wrong, he knew stuff about the mainframe that I will never know, because he's been in the mainframe world for forever. But he doesn't know anything outside the mainframe world. And that's sort of that's the gap that I've seen, is that there's the group here, the security people, and they know a little bit about mainframes, what they can gather online and whatnot, but they don't actually have access to one, or they don't and if you have access to it, you definitely can't fuck about it. I'm going to swear, so just FYI, you can't fuck around with a mainframe. If you have access to your corporate mainframe, you start fucking around, guess what? Your access is gone the next day. They're not going to let you keep mucking around, and if you bring down that mainframe, they're going to be so pissed, I can tell you what. So after that, I identified this gap, and so I started saying, like, I gotta start spreading the news. It's not, IBM says it's super duper secure, right? And some of the mainframers have drunk the Kool-Aid, and they think it's super duper secure. And so I started giving talks at various conferences, so this talk is going to be primarily about ZOS. I've already talked about that. I'm going to talk about TSO, BlackHat, JES, JCL, REX, OMBS. Everyone knows what that is, so I can just jump the next 20 slides and skip right into the tools.
ACF2.
I'm not talking about ACF2. I actually do have like a little bullet, but that's it. And then, but yeah, and top secret. That's the same bullet. And then, however, I will say, it's only a small part of the talk. I'm not focused entirely on BlackHat, on the security database. So, for everyone else that we were just talking in a foreign language, I'll explain what all these mean. So, who wants to tell me what they think this graph means?
Number of people that actually understood any of those terms?
That's probably pretty close to what that is, because I actually planned the question, but I'll skip the plant. It's the age of security administrators on the mainframe. So on the mainframe, and look, I'm not saying age is not a bad thing, except in 10 years, they're all going to be out of business. So the people who know more in their little pinky than I will ever know in my entire life about the mainframe, they're gone. And they're not answering the phone when I have a problem and be like, hey, what does this command mean? I'm like, fuck you, when I'm drinking martinis at 2 in the afternoon, I'm not answering this stupid question. So there's obviously a gap here as well. And I've asked IBM what are they doing about it, and they have a college program where you can go, but the college program is just to learn how to code on the mainframe. It has nothing to do with security at all. So, I mean, it's better than nothing, so these people can get access to a mainframe, but it has nothing, and I've actually used that mainframe to test some stuff out, but not part of the project. But, so, like I said, I'm not ageist. Okay? They're experts. But they grew up in the mainframe world. They grew up in that space. So to them, they didn't need to learn about networking, because that was network engineering's problem. They didn't need to worry about nmap scans or buffer overflows, because IBM said, oh, that can't happen on the mainframe. They didn't have to worry about those things. They definitely didn't worry about networking. And so this is an actual, from mainframe gurus, you can look it up. If you go to the site, someone asked a simple question. I need to do a reverse lookup from the IP address to the hostname. Now, if I said, how would you do that in Linux? Anyone want to take a guess how you do that in Linux? Someone want? Anyone on Wildcat? A little easier. You can just do NSLOOKUP, right? You can just do NSLOOKUP VIP address. Super duper easy. The answer the guy got was, you can't do it. It's not possible. There's nothing on the mainframe to do it. The next guy said, that guy's right, but you can write a program to do it. And I left it off because my slide was getting a little wordy, but the third guy said, you could probably do it with traceroute. I'm like, okay, well that guy's at least on the right path. Meanwhile, this is how you do a reverse lookup of an IP address on the mainframe. Right, it's not this terribly complicated thing. And my point of the talk, part of it is to sort of demystify this, this black box that only mainframe engineers can touch. It shouldn't be that way. You guys should be getting access to these things. You guys should be able, if they're saying security is as good as it is, if they're saying security is as good as it is, then why can't security experts get access to it to screw around with it? If it's that rock solid, what are they afraid of? So now I'm going to talk to you a little bit about IBM mainframes, because that's primarily the thrust of the talk. This is a really brief history. OS 360, released in the 60s. OS 370, released in the 70s. OS 380 didn't make it until 1995, so they called it OS 390. And then they realized that if they do OS 300, no one's going to buy a product that looks like going backwards, because they had a Y2K issue. So they released ZOS in 2004. All right? New release every 2 years. So it's, it's a current OS. Primarily when you're working on the mainframe, you're going to be using TN3270. That's that ugly green screen you see in like movies and whatnot. People are still using those. You might see like Costco. If you go to Costco, you'll see that screen when you forget your pass and to print your new one, they're going in. That's a TN3270 emulator. That's clear text. It's just an extension of Telnet. It's straight clear text. SSL was added about mid-90s by IBM, so kudos to IBM, they implemented encryption. But it's not forced, it's not required. So about 50% of mainframes that are available online are using SSL encryption. I've seen I think it's the University of South Carolina, their mainframe has non-encrypted and encrypted open, and they get to the same place. So I know full well no one's using the encrypted one except for maybe a couple of administrators, and everyone else is like, I can't do about this. So that's what I've seen. The problem is, everything on the mainframe is in ASCII. So you have ASCII, right? Everyone knows what ASCII does. When they were building up the mainframe, everything was written in ASCII because that's what came on the cards. Yeah, literally cards. And so it's a holdover from when cards were in ASCII. So now everything on the mainframe is all ASCII. But what's great is ASCII is supported in Wireshark. So here's a raw capture of me logging onto a mainframe. And when I click the ASCII button, boom, you get clear text. Impossible to read, almost impossible to decipher. That's my user ID right there. That was just a fake user ID that I was putting up there. That's a pain in the ass to look at, but. Now when you finally get access to the mainframe, you're going to be using a thing called TSO. TSO lets you run commands like I'll show you NSLOOKUP, FTP, traceroute, this DS, and this is the data set. What's really weird about TSO though is you have a username max of 7 characters. I don't know why. So next time if you go to like a bank website and your username can't start with a number and it can't have more than 7 characters, they're likely relying on the mainframe for your user management. So that way you can start saying, oh, this is probably using the mainframe somewhere. This is what it looks like. I executed a script that I wrote. I'm pinging BlackHat. It's not terribly complicated. A lot of the stuff I do is kind of a little cheeky. Like I don't know if anyone knows I have a Tumblr that I post all this stuff on because there's something so awesome about having mainframe stuff on a blog for like teenagers share porn on. Something so fun. It's something so ironic. But I was going to use MySpace, but then it turned into a music site. So. Now this is like a shell for the mainframe, and it's awfully used. And there's an editor, and it's horrible. So everyone uses the GUI, ISPF, or I think it's Interactive System Productivity Facility, which is a great name for a GUI. It rolls right off the tongue. It has a file browser. I mean, this operating system is by engineers for engineers, right? It's got a file browser, it's got this swanky editor, it's made of panels. So this is, I'm searching for files, I'm searching for the TCP/IP configuration files to see what's going on. Here's an editor. You can see it's got like some syntax highlighting, which is nice. It's got all kinds of stuff. And I'm sure a bunch of people are staring right here and saying like, what the hell is that about? And if I have time, I'll show you. Now, when I first started looking at mainframes, I would go in all young buck and be like, hey, I need to see your configuration files. And they would play dumb. They wouldn't even help me because I was an auditor. And they would say, we don't have any files on the mainframe. Oh my God, there's some people here who are like, oh, because they don't call them files. Because that would just be too easy, right? They call it data sets. Data sets are what you use to store everything on the mainframe, right? There are some stuff that's outside, but for sake of argument and time, that's what we'll say. Now it's composed of a high-level qualifier, so you see TCP/IP.FTP.data. The other two have names, but I just call them the rest, because I can't be bothered. Like it's like group and member or corporation, and it's all these weird names. So that's the high-level qualifier for this data set, and then that's the rest. Now you can take a file and you can partition it. So you can take one file that has, and it becomes almost like a folder to contain multiple files. It's called a partition data set, or PDS. So you'll see someone's call it PDS. And so here I'm looking at acid.jcl file. Now you would use this, for example, you have like 300 JCLs that you need, I'll talk about JCLs in a bit. This is what, so that's where it'd be stored. You don't want to have 300 and just hanging out with a high-level qualifier. And this is usually the talk. So when I first started giving this talk, I just sort of skipped over this piece, and then one time I gave a talk to a real small group, like 5 people, and we spent half an hour on this. Not this slide, but the next slide. And so I wanted to stop, and I wanted to explain, Unix is running in ZOS. Okay, it's a fully POSIX compliant environment. If you have TCP/IP, and you have all kinds of things like FTP, web servers, all that stuff, you're running Unix on your mainframe, right? That's all there is to know. It's not, it doesn't, like, so no one's minds are getting blown here. I see people right out of the room screaming. The command, so you won't see people call it Unix. If you were to talk to a mainframe guy, he'll just drop terms like OMBS. Like, I don't know what. Sure, yeah, it runs in the OMBS environment. Sure, I don't know what the hell that means. He's talking about Unix. OpenMBS is what OMBS stands for. So it really explains what the acronym is, right? So I don't know why that's just the command you execute. I'll give a demo real quick here. The best part about the Unix environment is if you're in this group, bpx.superuser, for any mainframers, it's actually a facility class, but for sake of argument, it's the same group. bpx.superuser, if you get access to someone's account with that credential, you type su in the Unix environment, you have root access to the box. Right? That's kind of awesome. So this is what Unix looks like. I'll skip through these because I'll just give a demo instead. But here you can see, so I ran netstat, I did a trace route, I did ID, just sort of normal Unixy type commands. All right, so let's do a quick demo. So you guys what this thing actually looks like here. So this work, does it disconnect? All right. I'm gonna log in here. Nope. Alright, so it takes a while to get going here. You can hear the gears crunching while this is happening. Okay, so here I am. I'm logged in. So I can type things like, so like I said, like netstat, right? I'm not going to do it because it takes a whole bunch of screens. But there's no concept of ifconfig on the mainframe, so what you can do is you type netstat home, and it shows you the network configuration. You can tell what ports and what IP addresses are configured and all that stuff. So let's go through. So you can list like data sets. Same thing as like ls, right? If you don't type it, it says, hey, you didn't give me what you want to look at. So I'm going to say, okay, I want to look at my home folder. Yeah, it's my home HRQ, whatever. So this is all that stuff that's going on there. Now remember I talked about like a partition data set that has members. So let's take a look at one. Let's see here. So I keep all my rec scripts, and I'll talk about what rec script is in a bit. But so here there's 2 members of this partition data set, game and terp. Terp is what I was using when I was writing on interpreter. So let's see. You can also FTP to places, right? So you can I can FTP out to a site. I just use this because I know it's up. Whatever. I don't know why I didn't. But if I want to get data off the mainframe, I could just connect and then put my files. It just works just like regular FTP. And then let's see here. So now I'll show you what. So like I said, OMBS. You just have OMBS. Boom. Unix prompt. Then I can do things like ID. Right. I can do uname -a. Right. That does it all. Let's see. I can do /netcat-h. And that's that's there. Notice I had to do that. / doesn't come with netcat. So I'll also be talking about that in a few minutes. Let's get out of the Unix environment because everyone knows Unix, right? Let's show you guys what that beautiful viewer looks like. So here I just searched real quick. Everyone missed it. I typed 3.4. That took me to utilities and file search. and then I put in my high-level qualifier for the file search, and that brought me here. So you can see these are all my files that I'm working on, all this fun stuff. So here's a file that's just, I'm going to edit the file, so I put an E in the command column, and then I'm not going to spend too much time, this is kind of getting boring, but, so I'm editing a file, and then here you can see the same thing, that one with the members, right? I was showing you guys that file, same deal. And now I can edit, say this file here, and there we go. Now I'm going to log off. That's what a mainframe looks like. Any questions? No, just kidding. So that's it. That's what a mainframe looks like. It's not that terribly scary. IBM publishes this stuff publicly on the internet, how to search for things, how to do things on the mainframe. It's not that complicated. It just takes time. Now, you saw me mention JCL earlier, I mentioned it briefly. Everything on the mainframe is a job. Everything on the mainframe is a maybe, so people will be saying no, not everything. Okay, not everything, but it's like the second thing that loads when you boot a mainframe. So everything on the mainframe is technically being a job for the sake of argument. It's managed by the job entry subsystem. So what a job is I submit a job, it goes into a queue, and depending on my authorization, it'll get X amount of CPU cycles. So you kind of want the accounting and payroll process to run before my stupid job that's going to do a netstat runs, right? That's more important than me knowing what reports are open. JCL is what you use to tell it to execute jobs. JCL is job control language. It's like a shell script, very similar, not terribly different. Has a job card and all that stuff. So here you can see, here's a job that I wrote. Here's the job card. It's all this, you can research it. I'm not going to go into specifics. Here's the program that I'm going to execute. BPX batch executes a program in the Unix environment. And then the parameters that I'm going to send to that program. And in this case, I'm executing netcat and opening up a listener shell on port 31337. I submit that, it executes, and boom, I can connect to netcat. And then there's a typo in my comment there, in case anyone wanted to call it out. Now, Rex. Rex is the equivalent of Python on the mainframe. Okay, that's all you need to know. I'm not going to spend much time. It's a scripting language. I'll show you what it looks like in a bit. It's the equivalent of Python. So this is what it looks like. It's really high level. It's not, you know, like everyone's like, oh, mainframes in COBOL. Oh my God. No, it's really easy. I can write in it. Anyone can write in the language, all right? Here's a simple program. All it does is it gets a random number, and it does some thing. It's just a really easy programming language. You don't need anything special. It has access to sockets. It has all kinds of cool stuff built into it. Now, so we talked about Rex, and we talked about stuff like when you're interacting with the mainframe. Now I'm going to talk to you about the master console. If someone gets access to your master console, your mainframe is owned, essentially. You're fucked. Right? This is what master console looks like. You know, on like a Cisco device and it has like a running tally, or like here's a better example. You type dmessage in Linux and it gives you the kernel output. Imagine if that was a rolling thing that you could interact with live. That's what the master console is. So for example, you would never want to do something like this. Right? So this thing tells it to say, hey, so in this file you can see here, the job known, let's see here, I can do, there, 5,000 jobs can run at the same time. Now I'm saying, just run 5. 5 is not that many, and you'll essentially stop the mainframe from processing jobs. Now you can do a lot worse than this, but I didn't want to talk in a conference about how much worse you can shut down some things since they're in banks and whatnot. But that's the kind of damage you can do with the master console. So if you know there's a master console out there, you want to find out who has access to it and how to protect it. Is it on a VLAN? Is it on a VPN? It's got to be way better than that. Just like hardwired into a console in the operations center maybe. Now this is my favorite part. FTP server. The FTP server runs on most mainframes. Everyone still uses it to transfer files. And there's this amazing feature. It's actually a built-in feature called site file equals jazz. Anyone want to take a guess what that does? Anyone? What if I said site file equals, the start of a bash script? Now, what if I said instead site file equals bash interpreter? No one? It executes the JCL file that I upload from FTP. So there was no RSA, so there was nothing back in the day. So I write a JCL file on my local machine, it uploads that file, and it executes it on the mainframe. All I need is FTP access. I don't need to have access to Team 3270. I don't need to have Telnet or SSH access to your box. I just need FTP access. Now you heard me mention RACF as well. I was talking to some people saying, oh, what about Top Secret and ICF2? RACF is the Resource Access Control Facility. Another great name. Rolls right off the tongue. You can replace it with ACF2 or Top Secret. Basically, when mainframes were built, the security was a dude in the data center that had a gun and checked your badge. There was no concept of security when they built the OS. So they had to put security on top of an already existing operating system. So it's more like a database that references all the files that are on the system and what you're allowed and not allowed to do with them. In RACF, the default user is IBM user and sys1. Top secret ACF2 don't have default users because it doesn't come with any. You have to set them up when you configure it from scratch. There's no concept of root, like I was saying. So because it's more like a database administrator paradigm. Special gives full control of the RACF system, which means they can technically get access to everything on the mainframe. Okay? If you're running RACF or ACF2, but specifically RACF, you need to limit who has read access to that database. You need to limit read access because it also stores the password hashes for every user on the system. And it used to be an obfuscated process of how they did it, but I'm going to share with you guys. It's DES. Yeah, it's DES. It's a one-way hash. So what they do is all they're doing is they're taking your user ID and they're encrypting it with your password. So I'll show you. So what they're doing is, here's my password for A's. That's C1 and Epsilon. That's the equivalent to that in binary. You take that, you XOR with X55, right? And then you shift it 1 bit, gets you hex 28. That's your value. So now my password in hex becomes this. And I feed it right into the algorithm. So now this algorithm is known. Now I'll explain why that's important later. Now you think this database has more than just password hashes. It has every single permission, all the password settings, every single access to every single resource, not just files, but also like what programs we can access. It has access to everything. So you think this would be really hard to figure out where it is, right? It's a core element of security on the mainframe. It should be impossible to even see where this file is. If you have a mainframe, I saw some people that assess them. If you have like the lowest level account, you just type rvary and it'll tell you exactly where the RACF database is. In this case, it's right there. Those two data sets right there. So then you know where it is. I don't know why they added that feature. It's great. All right, so now you're all mainframe experts. Everyone in the room. So you now know what JES is, what JCL is, what OBS is. You're all good. You guys are taking notes. I saw some people taking notes. Testing mainframe security. So when I came at this, I'm like, surely there's tools that exist out there to test the mainframe. It's been around forever, right? There's nothing. There's really nothing out there. It's really frustrating. There's nothing out there for the mainframe. The tools that are there are out of date or they're wrong. And there's no frameworks that include the OS as a whole. So here's Nmap, nothing. I did searches for more than this. It's just a nice little picture because it's boring to see our text. But the problem with Nmap as well is it's also kind of wrong when it does a scan of a mainframe. So here's an example. I don't remember what this mainframe was, but I redacted it for a reason. OS 390. Okay, so at least it's telling you OS 390. I don't think IIS normally runs on the telnet port on a system that is also running OS 390 on other ports, but sure, what the hell. Yeah, so that's weird, right? And the same thing down here, OS 390. I see OS 390 again. That's funny because OS 390 was discontinued in 2004, and if you see an OS 390 system out there, it's like 20 years old at this point. Right? So that's legacy. Like if you do see that, that's legacy. That's straight. But that doesn't exist because IBM has fantastic support contracts to make sure you buy the newest version. Yeah. So there are no OS 390 mainframes out there unless maybe in the Computer History Museum. There's no Nexus. You can see down there on Nexus. What's funny is I got into a discussion with Jack. He does like Paul.com. He talks about Nexus a lot. And he was telling me, oh, we have tons of mainframe stuff on Nexus. So well, not that I can find. Maybe I'm just an idiot. He says, I go, so what is it? He goes, we have tons of I-series testing. I said, oh, that's great. I'm talking about Z-series. So that may be a miscommunication. He's like, oh yeah, we have no Z-series. He's like, yeah, okay, well, that's what I thought. So there's nothing in Nessus, and again, there's nothing in Metasploits. There's nothing. But we know that there's problems, right? I've already talked about some of them. We know that the problem exists, and I'll show a couple more here in a few seconds. So we know the mass path, because it's DES has a max, the max key size is 56-bit. Well, it's technically 64 and they drop whatever, right? That makes it essentially, you can't have a password larger than 8 characters. You can't. You can implement passphrases, but I've never seen anyone implement passphrases. And IBM, you can implement passphrases on the mainframe, but you know what IBM does with it? They have an algorithm that just shrinks it to 8. And then they feed that into the DES algorithm. Right, isn't that funny? So it's a passphrase. We know it uses clear text, and you know FTP allows for code execution. But you saw one more. You saw one more when I was giving the demo. Did anyone catch it? This is like, pen testing 101 stuff. This is me logging in, normal user ID. This is me logging in, bad user ID. Anyone want to take a guess at what's the problem here? Anyone? What if I highlight it for you guys? What's that? No, it tells me straight up. It tells me straight up. It doesn't tell me my password's bad. It just tells me that that user doesn't exist. So it's being way too friendly, right? It's telling me that the user doesn't exist, and therefore I can use that to enumerate all the users on your mainframe. And I know what rules are involved in setting usernames, so I can use that to start enumerating users. That's hard-coded into the panel, by the way. You can't change it. There's no configuration to change that setting. It's just stuff like that.
Is there an audit log of that?
What's that?
Is there an audit log of that? If somebody runs, say, 50,000 combinations over 6 days, you're going to have...
Yeah, you'll catch it. You'll probably catch it.
Well, even if they don't set a password, they just type the name in and wait to see if it goes red or green, and then they backspace and go...
No, you have to hit enter. Because like TN3270, you have to send what's on the screen. It's not interactive. Now you can change it. And that's a good point, because 9 times out of 10, it won't be your security team that finds the problems. It'll be the operations team saying, we got some CPU usage, and that's going to cost us money. Right? It won't be this. It won't be like the logging people. If you're actually monitoring your mainframe logs, which you might not be. So this is frustrating because this has been like this for 20 years, but there's no support in it for THC Hydra and Medusa. So that's super frustrating. So I decided to write my own, just to see how hard it would be to do. Can it be done? I wrote a really bad first version last year. It was awful, but it was just pure proof of concept. Then I wrote another one called TSO Brute. Look how awful that looks. I don't know what I was drinking when I was writing this thing for sure. That looks like crap. So finally I decided to break it out. The TSO brute forced and enumerated, and I decided to break it out. And so now I'm releasing 2 tools. One's called Psychotic and one called Fatso. So they're much faster. They don't rely on, so TSO Brew relied on an external library, which relied on an external third-party program to connect to the mainframe. I decided to rewrite it from scratch and do all of the communication in Python, so it's a lot faster. And it's single purpose, so it's a little bit faster. So this is Psychotic. And you'll see a trend as we go on through the rest of the tools. I'm a big fan of ANSI art and ASCII art. So sometimes I spend more time on the art than the tool. So here you can see I'm just controlling through users, getting user IDs. This one will even tell you if your user's logged in, because the mainframe tells you if that user's already logged in. So it'll go through and say, this is a valid user, and they're logged in. So we know that it's an interactive account. So you can have accounts that are not interactive. And then Fatso just goes and it finds the password for you. And it has stuff built in to tell you, so you can see here, it skipped 2 usernames. That's because there's rules for what a password can be. There's lengths, and it can't start with this, it can't start with that. It can't contain certain characters. So that's all built into the tool so that you're not wasting your time trying to test this. So that's great. So one down, user enumeration. Now we have a tool. It's a horrible tool. I'm hoping someone takes interest and puts it in like some of the more mainstream tools. But let's talk about cracking the BlackHat passwords. This is what really brought me into the mainframe world. I just asked a question on Paul.com. Like, hey, does anyone know how to crack these things? And so I started working. We started figuring out. So I was working with Diru, who's part of the Open Wall team that run John Ripper. I was working with him and Nigel Penland. And Nigel Penland is the guy who actually figured out that algorithm. He's the one who figured out the algorithm that they used to obfuscate the password before they feed into the DES algorithm. And then Diru is the one who, working with Nigel, took that and converted it into 2 tools. BlackHat to John takes a BlackHat database and converts it into username and hashes, because the BlackHat database is massive, it's got a ton of information in it. And then John just cracks the password. Now Nigel also has tools. These tools are better suited for auditing instead of cracking. So if you want to know if hey, how many idiots have a 6-character password, that's the word summer, right? Well, this tool, you can use that. It won't tell you what the password is, but it'll say the first 2 letters. You can tell it, you can configure it however you want. And you can configure it to say, this user, and it'll actually use the BlackHat database to say, this user has admin privileges and has a weak password, and here's the first 2 characters of the password, right? And then here's like ***** to show you how long the password is. And it's a Windows-only tool. It runs in Windows. He released it last year, so we rewrote it. BlackHat is the first tool he released. All right, so now we can start cracking those hashes. We can start getting user IDs and passwords. Okay, so let's say we don't have access, so we want to start sniffing. We know it's clear text, right? So what do we want to do instead? we want to start sniffing the passwords. But I know, we know there's some support in Wireshark. We know, AirCap technically supports it. It just looks like crap because it doesn't have Ipsidic. But this is what it looks like, right? I showed you guys this earlier. Here's my user ID. And then way down there, there's my password. And that's okay for one person on a network, if I'm able to get this traffic. That's not really scalable, and I can't really just drop something and let it do that. I gotta analyze all this data. And looking at this, it's off. So I wrote another tool called the MF Sniffer. It uses Python and Scapy. Like I said, ASCII art, I'm a big fan. It'll sit on an interface, it'll open it up in promiscuous mode and sniff password. It'll sniff the user ID and password for a TSO login session. That's what it's doing. Now I would not use it, because the Scapy part will eat up all your RAM, because that's what happened when I have to reboot my machine. And instead, you can just use EtherCap, whatever. Diro took the tool that I wrote and said, hey, this is easy enough to make an EtherCap dissector, and he added that into that framework. So now you can just use that to man-in-the-middle attack someone and steal the mainframe credentials. There's my credentials right there. Much easier to read than that gobbledygook in Wireshark. Great. So now I'm starting to we got some accounts, we got all that kind of stuff. Now the fun one, this is my favorite one, the FTP part. Before I get into the FTP, I want to talk about netcat. So when I first started getting access to the mainframe, I was like, man, it would be great with netcat, because then I can start doing some cool things in the Unix environment. But when I tried to compile it, it just totally crapped out. So I had to change some of the source code. This is the historical version of netcat. I couldn't get the most recent one to compile. It's a little too complicated for the compiler. I know OMBS. But I had to make OMBS option to netcat. This is on my GitHub, and I'll have a link at the end. So when you do this, it gives you a full netcat like you saw. I just typed /h. There's only one problem though. Anyone want to guess what the problem is? So here I set up a listener. It's the same damn problem we have every damn time. It's Ipsidic. Ipsidic all the damn time. That son of a bitch. Every time. So I wrote a script called net-ipsidicat. So I thought that was clever. It comes with netcat. It's in the Python script folder. It translates Ipsidic to ASCII so you can actually communicate with the netcat listener or reverse shell. So here, for example, I set up a listener shell. And then with net-ipsidicat I connected, and I'm running commands in netcat interactively. I also made this lovely ASCII. Anyone was wondering. No, I realized by the time I made it to this tool, I was like, not everyone wants to see my stupid jokes. So this is optional. You have to pass a command to see the logo. It's sort of secret. Now I have netcat. Now I want to use FTP to execute it. The only thing I have is FTP access. I don't have access to any other resource. Because a lot of times companies put their FTP externally facing because they need to talk to their bank, they need to talk to their insurance provider, and they say, FTP is safe, right? So they give people credentials and they start moving files around. So the first thing I do is I upload the netcat binary, and the second thing I do is I upload the JCL to execute that binary. Here's the JCL that I wrote to do that. You can see here, up here, you can see the job card. I said I wouldn't go to detail last time, but this time I am. You can see there's no limit here, so it won't time out. And this message level here, this means, so if you're looking at the logs of what happened in Jez, it'll go, okay, it'll show this, and stop here. And won't show what was actually executed. That's what it shows in the logs for Jez. Right, that's what that message level nothing means. All right, so here you go. So there's UPX batch. I told you guys to execute something in Unix, and then I'm copying the file to the temp folder, then I'm making an executable, then I'm executing it. All from FTP. So how do I do this? First I convert it to binary mode, because I'm going to upload a binary, because if I don't, it's going to translate it from, it's already Ipsidic on my computer, so it's going to take it thinking it's ASCII and try to translate it, and then my program won't work. Then I upload the netcat binary, then I convert back to ASCII. I didn't have to do that, but I did. Then I change, this one is the big guy here, site file equals Jez, I convert to that, and then I put my JCL file, and then you can see down here, and then I connect with net-ipsidic on the next slide. But here you can see, okay, here we go, we're going to put it in, and then it's known as this job, and it's transferred, and then it's done. It executed that file for me. And here I am, and I just connected, same port, same everything, and I got the same level of access. But that's awful, having to do that all by hand. I said, oh, that sucks. I don't want to do that every time. So I wrote a script called maintp. This one actually has an animated ASCII art, which doesn't display well in slides, and I wasn't going to waste time recording it, so check it out. But it turns FTP only access into shell access. It includes net-ipsidicat, it includes a base64 encoded binary of netcat. It's all one script. You run it, you point out the mainframe, username, password, and you get a shell. It generates random job card information, so it'll be random information at the top, so it's not always going to be the same. And then it deletes all the files when it's done. So you upload, it does all its work, everything gets deleted when you're done. This is what it looks like here. You can see the main TP, and it does its thing, and then it's got, connects to the shell. And I got it. Same stuff, same commands, same thing I had before. Now what's interesting with this script is I decided to put a verbose mode in so everyone can follow and see what's going on. So if you just put a V, it'll show you exactly what JCL it's about to upload to the machine. And it'll show you what username, what password, all the results of the FTP upload, just so you can follow along so you're not operating in a black box. Now, the problem is, I don't want to be in the Unix environment all the time. The Unix environment generally is not where things are on the mainframe. The TSO environment is where everything is. We talked about TSO, that ugly red screen. That's where everything is. That's where the hotness is. I don't want to be in Unix. There might be some website configuration files, but there's no data there, predominantly. And the other thing is you need your own BS access. Not all users are giving Unix access on the mainframe. If you have FTP access, you might have it in a misconfigured mainframe, but generally you don't have that access. So I wrote another script called Catso. So Catso is a Rex script. So you saw Rex earlier. I call it interpreter-like. And what it does is it allows you to interact with the mainframe and send Unix command or TSO commands, or just general stuff. I know not everyone's a mainframe expert, so they don't know how to do things. So I decided to higher level that shit so you guys can actually do some stuff. So here it is. It looks like, you type case. So I'm executing it. It can be listener or reverse mode. And then here I connect with netcat, and then I execute a command in the Unix environment, so I can execute commands in Unix. So now I wanted to see the contents of the file, so I cat the file. Cat doesn't exist. It's just the Rex script interprets it and says, okay, it does all these things behind the scenes and shows you the contents of the file. So you run the command, and I cat the file, and boom, you get the contents of the file. Catso is, I wrote it sort of in a vacuum, so it's portable, but you need access to the mainframe. You got to be able to put it in a file and then execute it from the TSO environment. Or you need to put in JCL. The problem is in JCL you can't. So JCL lets you sometimes, Java control language, you can compile COBOL straight in JCL. So you put COBOL, you surround it with JCL, and you send it, and it compiles it and executes it. You can't do that with Rex. So there was a little bit of a problem here. So I did some research and I came up with what's called the sandwich. So here's the top, it's two parts, this is one JCL file. Two things are happening, there's two job steps. You have this one which says, hey, take the file, that's here, this is the file that we have, it's really big so I didn't include it, and put it in this temporary file, right? So temporary data set with this member. And then down here it says, hey, execute that member with this. Okay, everyone following along? But that's awful, I don't expect everyone to know JCL and learn JCL and do all that kind of stuff. So I decided to, again, high level that stuff and make another Python script called Shocker. It uses that JCL file and uses some other things to be able to, so it uses FTP, it uploads the file, it uploads just the JCL file, and then you connect and you execute and you do all kinds of fun things on the mainframe. So here it is in action. I just ran it, and then here I connect with Metasploit. It's just using just a bind handler, so it's not really anything special. You can type all kinds of fun stuff. And the same thing with netcat, you can just connect with netcat. And again, another wonderful ASCII logo. And let me give you guys a quick demo of that tool here. Let's see if I still connected. Ready? Let's see, let's make this easier. So I don't have to. I was testing it out earlier. Let's do it. So here I can see the dash logo, that means that you guys see my pretty logo. So here's just connecting to the mainframe. That's it, that's all, that's how long it took. That's it, no time at all. And then all I'm gonna do is I'm gonna use netcat because I don't want to spend the time loading up Metasploit. I'm just gonna connect. Now I have an interactive prompt on the mainframe. Right? It has all kinds of commands you can execute. Let's scroll up here, let's see. So I can copy stuff, I can do an ls, I can show. Now ls is going to take a while, but you can see it lists all the files that we had before. You can do things like cd, so I can cd into say TCP IP. Let's see if this is going to work. All these files are there, right? I can do, let's see, I can show where am I at right now. I'm in the TCP. I can do Let's see what else can I do. I can get my user ID. I can get the location of the RACF database. Okay. I can also execute TSO commands. So let's see, I think I said it's TSO and execute. Yeah, down there. So I can do TSO commands. Okay. Let's see, this word. Same way to get the RACF database instead of just typing RACF. I can also do Unix commands. So I can execute commands in the Unix environment, all from one script that I uploaded through FTP. And this actually supports reverse lookup as well. So instead of doing, I just do a listener because it's easier, because I can do it with BlackHat real quick. But you can also use that to do a reverse connection back. So generally, if the mainframe is behind a firewall, you can just say, connect to the server over here using the reverse connection. And it'll be the same interface, the same prompt. Let's see here. So that's my awesome BlackHat demo. Great, so now we've tackled some of these things, and I'm hoping, and I'm working on getting some of these things implemented into Metasploit. I need everyone's help, because it's a very challenging environment. You can understand that some people don't want these things developed, so I can't ask for help from mainframe gurus. And the security community is not terribly interested. In fact, I'm actually quite surprised at how many people are in the room right now. To be honest, I think some people show up here by accident. Like, I'm just here for the next talk. So how can you help? You can emulate a mainframe at home. You can run a mainframe. Like I said earlier, like they don't want to give you access to the production mainframes because they don't want you fucking around with production data. Fine. Your corporation likely has access to ZPDT, the Z Professional Development Personal Development Tool. If you have an expensive mainframe, IBM probably gives this to you as part of your package. It comes on a laptop, an IBM laptop, not too dissimilar to this one down here, and you have a full-on mainframe environment that you are responsible for and responsible for managing. You can also emulate a mainframe in Hercules. Hercules is an open source emulator that's continually being updated. It's a fantastic tool. It runs in Windows, Unix, Mac, all kinds of places. This is what Hercules looks like. So when you're running a system, you can see there's all these things running and all that stuff. So that's the end of the talk. Is there any questions? Oh wait, I have one more thing. I didn't know if I was going to have time, so I didn't want to. Let's see here.
I got a question.
Yeah.
So if you do a port scan, how many FTP sites do you find?
So I think there were 600 from the internet census. You guys remember the internet census that happened over like 2012 when the guy scanned the entire internet? There were 600 plus FTP mainframes on the web. Just on the web. I guarantee every mainframe has that's the question. Oh, so the question was how many of them are running FTP on the internet? Almost guaranteed all the mainframes are running FTP because that's how mainframers used to get files on off the mainframe. But how many are internet exposed? 600. I think that's a good number. Let me see. So I'm also working on this. Can I do this one? Oh, that's much bigger. So on the right, you can see this is the beginnings of a Metasploit interpreter in Rex, and on the other side is going to be the Metasploit handler. So right now it's using, because there's no ZOS is not an architecture in Metasploit right now, and if anyone wants to volunteer to help me build it, that'd be great, because there's not much technical documentation for Metasploit, and it's a pain in the ass to try to do things in that environment. If I wanted to write an exploit for Windows, there's tons of articles. Nothing for mainframe, or even adding architecture. So here you can see I'm just setting it up. This video is a little slow, so we'll just speed that up. You can see here I'm setting up commands and whatnot. And then, okay, so now it's gonna wait for a connection from the mainframe. And on the other side, I'm gonna execute it. Like I said, it's very, very beginner stage of stuff to execute it mainly on the mainframe. There's no reason why you couldn't do this through JCL like I was doing with the other side. And there we go. Now I have an interpreter prompt. I can do sysinfo. There's not many commands implemented right now. You can see there's only like a handful of stuff. And then on the other side is sort of a debugging log that I have in compose mode to be able to do. I know there's some questions, so while this is playing.
If you could use the microphone, please do so, otherwise talk louder.
Do you see a lot of Linux running on L bars still, or is that kind of going away with it?
It's funny because I was just talking about that this morning. IBM is really pushing for the Linux on mainframes, right? Because it costs them nothing to support because it's an open source operating system, and it means you're buying their hardware, so they're selling the hardware, and you don't own the hardware, you license it, and you license you may buy a box with 110 CPUs and you're licensing 50. And so if you have to use 51 for like a day, you're paying for that 1 day of using that one extra CPU. That's how they're billing you. So yeah, IBM is certainly going. I haven't seen any in the wild. There's guys on how to implement it, but IBM is pushing it. Like if you follow them on Twitter, that's all. They never talk about like ZOS unless there's a new version release. They're always pushing their Linux platform. Anyone else? I know there was. Yeah.
Yeah. How about the iOS side of the mainframe kind of stuff? Any of your scripts translate over that?
The iOS. The iSeries stuff.
The iSeries.
Like the AS400s. So the AS400s does have some stuff that's very similar, but there's like a 400-page book on how to hack AS400s. There's no books on this. So they may be portable. There are similar concepts. Like you can do the FTP attack in AS400. That exists. Because I was doing some research and I came up with some research for AS400. So I know that exists, but I've never tested it. I don't have access. There's a whole bunch of stuff on AS400 that market's taken care of. So I don't really muck around. I think this guy had it enough from Mexico.
How many of the problems you exploited can be fixed by changing configuration on the mainframe? And how many of them do we need to get back to IBM to have them redesigned?
So the TSO, okay, so let's go through them. So the clear text passwords and stuff, that's already fixed. SSL is available. There's no reason why you should be running SSL today. There's no reason why you should not be running SSL. You might hear maybe some mainframers say, oh, my system resources, oh no. That's not really an issue anymore because we're not living in 1979. So encryption really does not add that much overhead to a system that has like gigaflops of processing power. So that one's already taken care of. The other one is the user enumeration. That's hard-coded in the panel, so that's something IBM's going to have to either care enough about fixing or just say, no, we just implemented a new logging feature, and that's how we're going to mitigate that. You can bypass that whole panel, so you can write your own script to do logins. That costs money and expertise that people generally don't have. Remember that age graph I showed you? Those guys that are 50 plus, they're not making 30 grand a year writing mainframe apps. They're making a lot more. So generally companies are just going to use that login panel, and you can't change it. Someone tried to argue with me and said, oh, you can totally change it. Like, great, tell me, I want to know how to fix it. He said, oh, you just replace it with this program that you have to write by hand in C and test and do all that stuff, so that's awesome. The FTP one is a little bit more challenging. You can limit people's ability to run jobs, period, but you can't limit their ability to run jobs from the FTP client. You can't say, only let jobs run in FTP, or only allow jobs to run in the TSO environment, but don't allow them to submit jobs anywhere else. The facility class is called JES commands. That's what allows access to run those commands. And when you get access to a mainframe, even when you log in, you're executing a job that's executing your TSO environment. So removing that access is not. Now you can disable that feature, period, in the mainframe. Just say AFTP, don't allow JCL. You can turn that off. But there's companies still use it today to be able to do remote execution of jobs like on a timed schedule. Some guy at another conference came up to me and he said, I'm glad you gave this talk because now I can go tell them to start cleaning up because they had a Windows box that was submitting JCLs to the mainframe. And it had like username and passwords in the scripts that they were using. And I can tell them there's a hacker talking about this, so they're going to have to clean it up. I said, yeah, good luck with it. No, literally, I got into a discussion online and the guy, I was saying like, oh, John the Ripper supports the hashes now. He's like, that doesn't matter to the mainframe. It doesn't matter to the ZOS environment. Because you can't compile and run John the Ripper on the mainframe. It's like, oh, buddy. You fundamentally do not get what John is doing, do you? Why would I run it on the mainframe in the first place? And then the last one, I think that was it. The three. But FTP, you can't really, I mean, you could disable it. You could not allow FTP accounts access to Unix or TSO environments. That would be another way to do it. But that's generally, there has to be some changes coming up from IBM to be able to fix that. But I don't know if they're working, I don't know if anyone cares. When I bring this up to mainframes, they're like, yeah, that's what we use to do remote execution. We use. Yeah.
Is there an easy way to search or a tool that requires to actually find sensitive data installed in the mainframe?
Yeah, you can. Well, I mean, if you have a TM3270, yeah. Oh, he asked, is there an easy way to do searches for sensitive data? So I know, I can't remember the guy's name. If you look up the guy who invented ACF2, He has a company and they offer a service to do that. I don't know if there's any tools that do that specifically. You can for sure write tools to do it. I'm not gonna, it shuts down the mainframe because it's so IO intensive that it just brings the mainframe to a call. It takes like 2 hours to search one high-level qualifier, so it's awful. But there are, instead what you would just use is if you can get access to the 3270 client, like that green screen, you can just do a search in there and just start trolling through the data if you really wanted to. That's the other problem with a lot of mainframes is they tend to atrophy over time. So you end up with a lot of data that's sitting on these mainframes that no one knows what it's for, and it's not really labeled well. So you have all these high-level qualifiers because they're limited to 8 characters. So they have the most complicated, like, TP226X dot June dot DF. I don't know what that means. And then you ask them, say, what is this file for? And they say, oh, we think it was for a legacy app that's been since removed. But we don't want to touch it because we don't want to shut down the mainframe. I've had discussions like that. Anyone, any other questions? Yeah.
Let's go with the FTP stuff. Relay command. I think we have another relay command channels being there, out there.
Didn't hear you too well.
The FTP stuff that you did demonstrate.
Yeah.
Let's call that the relay command experience.
Yep.
FTP being the principal.
Yes.
Are you aware of any other thread support?
So you can do, I think it supports RSH, I think, in the Unix environment. So you can use that way. There was recently, well, a year ago, IBM quietly released a CVE for remote code execution through their web server. I am slowly, I have a 1-year-old at home, so very slowly in my spare time, trying to research exactly what that patch fixed to see what they did and what was wrong. I got a cryptic email from someone when I posted on Twitter. I was like, hey, what the hell is this about? And he's like, look in the past of Unix. And then I emailed him back and the account was deleted. I was like, all right, weirdo. That's great. So, yeah. I think I saw another question.
Does the mainframes have password lockout?
Yeah, they do. You can set it. You can set it in BlackHat. There's a setting to say after 5 tries, lock out the account. You can also set how many times a user can try user ID before you kick them off the mainframe. You can't ban the IP address, but you can at least close the connection. And my script's the one that does like psychotic. It anticipates that and it just continues the connection after you get kicked off. But 1 second. The other thing I didn't talk about RACF. I'm sorry, I got 1 minute left. RACF, you can set no mixed case on the passwords. And there's mainframes today that are still running no mixed case and minimum of 6 characters and no complexity. So if you guys have the time, take a look at the logical breach. Because that's what happened there. There were passwords like summer, not cats. So I know over here had a question?
Yeah, just a quick one on security patch. You already mentioned CVE. Do they sneak in stuff and just don't document it on updates? Is that the
They never. Now what's funny is they never, it's so high level. And it was like a critical, 2 of these things that came out last year were critical CVEs for IBM mainframes. And then and then they released the patch, and all the mainframers implemented the patch because they're just trained to do patching. Patching is really great on the mainframe. They're just trained. They just stick the patch straight in there so there's no problems. And then they, I guarantee it's patched by now on almost all mainframes. But yeah, they very quietly say, here's the CVE. It allows for this. Here's the patch. So, in fact, when I talked to the mainframe people at our company, they were like, well, I didn't know it did that. I just installed the APAR. I think I saw one more. Yeah.
Did you use your,
What's that?
did you use your Tumblr link?
Yeah, sorry. I should have left that on the screen instead of this stupid screenshot. So there you go. Everything's mainframed, the D767. So, if you have any more questions, I'm just gonna, we can talk in the hall or we can chat at coffee time. Otherwise, thank you very much.